Imagine yourself standing alone in the heart of the wilderness, far from the hustle of everyday life. The only company you have is the cold, crisp air and the vast sky above you. Suddenly, the darkness of the night begins to shift, as though the very stars themselves are waking up. And then you see it. The aurora, ribbons of light flowing across the heavens, stretching from horizon to horizon. Shades of green, violet, and deep reds undulate and flicker like the pulse of the earth itself. For centuries, this natural light show has inspired awe and wonder, sparking myths, stories, and legends. People have seen the aurora as a message from the heavens, an omen, or even the work of gods. But as breathtaking as it is, the truth behind the aurora is far more extraordinary and far more complex. It is not just a phenomenon of light. It is the result of the immense power of our closest star, the Sun, and the interactions between its fiery energy and the Earth's own magnetic forces. These lights are the aftermath of an invisible cosmic storm, a storm that is driven by the Sun itself. This is space weather, a phenomenon that doesn't just create beautiful auroras. It can also bring destructive consequences to our world. The same forces that give us these lights can threaten everything we depend on. To understand space weather, we first need to uncover the mystery of how the auroras form. It all starts with our Sun, a massive ball of hot, glowing plasma. Every second, the Sun is releasing enormous amounts of energy in the form of charged particles, known as solar wind. This invisible wind blows constantly outward, sweeping through the solar system, reaching all the planets, including Earth. These particles are like an invisible flood racing through space. But when they reach Earth, they encounter our planet's magnetic field, a force that surrounds our planet, acting as a protective shield against much of the harmful radiation from space. This magnetic field is like an invisible bubble stretching far into space, guiding these solar particles toward the poles. When these charged particles collide with Earth's upper atmosphere, at altitudes between 50 and 150 miles, something incredible happens. As the solar particles strike atoms and molecules in the atmosphere, energy is released in the form of light. This light is what we see as the aurora. The type of gas and the altitude of the collision determines the colors. Oxygen at higher altitudes produces red and green, while nitrogen gives us purples and pinks. The auroras are not just beautiful. They are nature's way of showing us the Sun's immense power, a power that stretches millions of miles, from the Sun itself to the poles of our planet. Every time we watch the auroras, we are witnessing the Sun's energy in action. But while the aurora is a visual treat, space weather is not all beauty. Space weather, as we call it, is the term used to describe the conditions in space that arise from solar activity. It refers to the dynamic and sometimes dangerous interactions between the Sun's output and Earth's magnetic field, atmosphere, and technological systems. Space weather isn't limited to the auroras. It also encompasses solar flares, violent bursts of radiation that explode from the Sun's surface. These flares release vast amounts of energy and can travel to Earth in just a few minutes, disrupting communications and satellite operations. But it is the CMEs, massive eruptions of solar plasma, that pose the greatest risk. Coronal mass ejections are far larger than solar flares. These are giant clouds of charged particles and magnetic fields blasted out from the Sun's corona, traveling at speeds of up to 3 million miles per hour. CMEs can take anywhere from 18 to 72 hours to reach Earth, depending on their speed. When they strike our planet's magnetic field, they can cause a geomagnetic storm, a violent disturbance that can affect everything from GPS systems to power grids. When these storms hit, the effects can be far-reaching. The auroras we see are just a visible sign of these interactions. The true impact lies in how space weather disrupts our modern infrastructure. While the auroras are a magnificent byproduct of solar activity, the same space weather that creates them can also bring devastating consequences. When solar flares and CMEs reach Earth, their effects can range from minor disruptions to potentially catastrophic events. It is not just the beauty of the auroras that should concern us. It is the hidden power of space weather that threatens our technology, our communication systems, and even our way of life. In 1989, a solar storm knocked out the power in Quebec, Canada, affecting millions of people. The storm, caused by a massive CME, was so powerful that it induced electric currents in power lines, damaging transformers and shutting down electrical grids. This wasn't just a minor inconvenience. It was a full-scale blackout that lasted for hours, with long-term consequences. And this wasn't an isolated event. It was a reminder that space weather has the potential to wreak havoc on our vulnerable infrastructure. More recently, space weather has affected satellite communications, GPS navigation, and even military operations. The 2003 Halloween storms, a series of solar flares, wreaked havoc on satellite systems, with communications being interrupted for hours and causing disruptions in aviation as well. These storms even affected astronauts on the International Space Station, with higher than normal levels of radiation forcing them to take shelter in safer areas of the station. Imagine a storm of such magnitude today. The Carrington event of 1859, one of the largest solar storms ever recorded, sent shockwaves through the Earth's magnetic field, sparking fires in telegraph systems and causing widespread disruption. If an event of that scale were to strike today, the results would be catastrophic. Satellites that guide everything from communications to weather forecasts would be knocked out. Power grids would collapse, plunging entire cities into darkness. Transportation networks, from air travel to shipping, could be paralyzed. While the dangers are clear, there is hope. As we move further into the 21st century, our ability to predict and prepare for space weather has improved drastically. Using advanced technology, scientists have made great strides in monitoring solar activity and understanding how space weather impacts our planet. Satellites like NASA's Solar Dynamics Observatory and the European Space Agency's Solar Orbiter allow us to track solar flares and CMEs in real time. By monitoring the sun's behavior, we can predict when a solar storm is likely to hit Earth. Early warnings give us the chance to prepare, from rerouting airline flights to powering down vulnerable satellites, and even temporarily shutting down sections of power grids to avoid damage. While we cannot prevent space weather, we are learning how to mitigate its impacts. Just as meteorologists track storms on Earth, we are now tracking the storms of space, using that information to protect the systems that power our lives. And it's not just space agencies that are preparing. Industries are taking action too. Power companies, satellite operators, and even airlines are working together to reduce the risks posed by space weather. As we gaze up at the auroras, we are reminded of the dynamic relationship between Earth and the Sun, a relationship that is both beautiful and unpredictable. These lights are a testament to the incredible power of the solar wind, a reminder of the forces that shape our planet and our technology. But they also carry a deeper message. Space weather is not just a natural phenomenon. It's a force we must learn to understand and respect. By continuing to study the sun, we can better prepare for the challenges ahead. The auroras will always be there, beautiful, mysterious, and awe-inspiring. But as we face the future, understanding space weather is no longer just a matter of wonder. It's a matter of survival.